All right, the infamous diving board problem. All right, so here's the deal. So number 6 says Dennis is going to go do some sort of crazy super dive. All right, it tells you that he stands at the end of the board. So here's Dennis. Hello. Okay, the problem tells you that his mass is 125 kilograms. So what should I do with that, you guys? Multiply by 9.8 to get it into newtons. So here's the force from Dennis. 125 times 9.8 gives you 1225. Good? All right. The problem tells us that the board is a stupid 5.5 meters long. So many people divided that in half wrong. Yeah, a ton of people did. All right. Okay, so let's see. It says it's attached to 2 supports. The 2 supports are 1.5 meters apart, and one of them is at the opposite end of the board as Dennis. So you've got 2 supports holding this thing. But one of them is at the opposite end of the board, so they got to be like this. Okay, so here you go. Support 1, support 2, and they are 1.5 meters apart. Okay? Now, the uniform mass is 40 kilograms. What's the significance of that word uniform, you guys? The center of gravity is in the middle. Okay? So if it doesn't say otherwise, you can always assume stuff is uniform. All right? So here's my center of mass. Half of 5.5 is 2.75. What did I say? 40 kilograms? So that's 40 times 9.8 is 392 newtons. Cool? Is everybody good up to there? All right, so what do we got? 2 unknown forces or 1 and a distance? 2 unknown forces. The 2 supports, right? So these ones you solve differently. When you have 2 unknown forces, you have to pick your pivot point at one of the unknown forces. So I need to pick my pivot point to be either here or here. Let's pick one. What do you got? Left? Great. All right, there's my pivot point. Good? All right, so it's got to be true that the net torque about that point has to be 0. So the net torque is the torque from support 1 plus the torque from support 2 plus the torque from gravity plus the torque from Dennis. Good? All right, what's my net torque, you guys? 0. Torque from support 1. 0. Does anybody not see why that's 0? Plus the force of support 1, which I don't know, times, or sorry, support 2, times 1.5 meters, plus the torque from gravity, which is 392 times 2.75, plus the torque from Dennis, which is 1225 times 5.5. Cool? Did I do that too fast? Sandy, good? Everybody set? Okay. Now let's go in and put our negatives. 0 is 0. This one I don't know. 392. So that's pulling down. Is that going to make it go clockwise or counter? Clockwise. So that one's negative. And I think Dennis gives the same result, right? Negative. Follow? Yeah?
If you had in your pivot point, the second one, would the distance have to be negative 1.5?
No.
It wouldn't?
No. Your torque. No. I never put any negatives in here except to establish the torque. All right? And so what would end up happening there is you'd go through and do the math, and what the math would actually... May I come back to that question in a minute? Because I don't want to... There's something weird about support 1. All right, so is everybody good with what I've done here? Okay, so solve it. So you end up with the force of support 2 times 1.5 equals some positive number. Okay? Which means it has to provide a positive torque. So which way does support 2 have to push to create positive torque? Which way is positive torque? Clockwise or counter? Counterclockwise, right? So if I apply a force here and I want it to go counterclockwise, that means I got to push up, right? Good?
So
All right, and if you do the math, you end up getting, it's like 5,320 or something like that. Does that, anybody tell me what it is? 53.
For one of 5209 is one of them.
52, oh, 5210, that's right. Okay, so anyway, it's somewhere in that neighborhood.
Yeah, no, that's right.
Good?
Yes.
All right, so now that I've got that, how do I find the other force? In one step. You can do a different pivot point, but that's the hard way to do it. I'm not going to ask Liz because she answered this question the last time I asked the same question. All right, what do you got, Adrian?
So you can cancel out all the forces. Like, you know that it has to counter, the second one will have to counterweight that one.
So summarize that. What are you going to do?
Set it up so everything's 0.
So your net force is 0. Set net force equal to 0 and solve it. Good? All right, and if you do that, what you end up finding is that the force of support 1 is negative 3,000 something be something. Cool? So is everybody okay with that? Set net force equal to 0 and solve for support 1. You get negative 3,000 and something newtons. Why is it negative? Let's think about that. So look, you guys, if these are the two supports, and this is the diving board, if Dennis walks to the end of the board, this is holding everything up, right? But what am I doing over here with my thumb? What happens if I let go with my thumb? Flips over, right? So there has to be a downward force at this end to prevent the board from going, wah.
Mr. Hecker,
Yep.
in like real life, would it actually be that like one of them's doing all of it and the other one's doing like the opposite, or would they both be doing a combination?
No, that's exactly this. Yeah, one of them would be pushing, holding all of the weight and counteracting the downward force of the other one. Yeah. Does that make sense, you guys? All right, so let me go back to Savannah's question before. If you had chosen your pivot point to be here and you set it up, what ends up happening is you discover that the torque from support 1 has to be positive, which then means it has to be pulling down. Okay? But no, I would never make a distance negative. Okay? Yeah. Good? All right, that took longer than I hoped it would, but based on how much my 6 hours struggled, I felt like it was needed. All right, any other last minute questions? Okay, cool. Then, I'm going to pass out the target check.